What if I told you that everything you see, from the most distant galaxies to the coffee cup right here on your desk, is fundamentally mathematics? It's not just described by math, it is literally composed of it. Today, we're diving deep into one of the boldest and most mind-bending concepts in modern science, the mathematical universe hypothesis. We'll try to tackle the ultimate timeless question: is God, in fact, mathematics? Stick around till the end of this video, and you'll discover why some of the world's leading physicists believe we reside inside a massive mathematical structure, and more importantly, what this means for our understanding of reality, consciousness, and perhaps even the divine itself. The idea that the world is fundamentally built upon numbers is, in fact, nothing new. It dates back to the 6th century BC, when the ancient Greek philosopher Pythagoras famously proclaimed, "All is number." He and his followers believed that the harmony of the cosmos, musical intervals, and the motions of the planets were all dictated by precise mathematical relationships. Later, Plato expanded on this, proposing that our physical world is merely a shadow, an imperfect reflection of a greater realm of ideal forms, a realm that is inherently mathematical. For millennia, however, this remained firmly in the territory of pure philosophy. It wasn't until the 21st century that the physicist and cosmologist Max Tegmark took this ancient idea and formalized it into a rigorous scientific hypothesis, one that has the potential to turn our understanding of reality completely on its head. So, let's introduce the central figure of our discussion. Max Tegmark, an MIT professor, formally presented his mathematical universe hypothesis, or MUH for short. The core of this idea can be summarized in one shocking sentence: our external physical reality is a mathematical structure. This doesn't just mean the world resembles mathematics. It means the world is mathematics. Tegmark argues that everything in the universe, including you and me, is simply a component of a gigantic mathematical object. Every property of our reality, from the mass of an electron to the curvature of space-time, can be reduced entirely to mathematical properties. This represents a radical shift in perspective. We are accustomed to seeing mathematics as merely a tool, a language we use to describe the world, but Tegmark argues, no, the language is the reality. To understand the origin of this truly mind-boggling idea, we first have to address the fundamental question that even haunted Albert Einstein. Why is mathematics so unreasonably effective at describing the universe? Just think about it. Physicists sit in their offices, scribbling abstract equations on whiteboards, and then astronomers point their telescopes skyward and find the very objects these equations predicted. This is how we discovered the planet Neptune, predicted gravitational waves, and eventually found the Higgs boson. How is it possible that these abstract symbols, generated purely by the human mind, can so precisely describe the fundamental laws of nature? If the universe itself is a mathematical structure, the mystery simply vanishes. Mathematics isn't effective because we stumbled upon a successful way to describe the world. It is effective because we are using mathematics to describe mathematics. It's the equivalent of describing an apple using the word apple. The match is 100% perfect. Let's dive deeper into this philosophical debate. There are two main perspectives on the nature of mathematics. The first, and arguably the more common one, is called formalism. It essentially states that math is nothing more than a set of rules and axioms invented by humans. Think of it like chess. We created the rules ourselves, and the pieces move accordingly. Mathematical objects, like numbers or triangles, don't exist somewhere out there in reality. They only exist in our minds as useful concepts. The second perspective is Platonism. This view posits that mathematical structures exist objectively and independently of us. We don't invent them, we discover them, much like Columbus discovered America. A triangle with its property that its angles sum up to 180 degrees would still exist, even if humanity had never appeared in the universe. Tegmark's hypothesis is fundamentally the most radical form of Platonism. Tegmark goes even further and posits this: if you believe in an external reality that exists completely independently of humans, then you must accept that this reality is inherently a mathematical structure. Why? Imagine this external reality. For it to be truly independent of us, it cannot contain any human-derived concepts whatsoever. Words like chair, rock, or blue colour are all merely labels invented by our brains. They are not the fundamental properties of the universe. The only thing that can exist without this human baggage are abstract relationships and structures. And what is the science devoted to abstract structures? Precisely, mathematics. Any physical law we discover is essentially the detection of a mathematical regularity inherent in nature itself. Therefore, following Tegmark's logic, if an external world truly exists, it has no choice but to be mathematics. This idea brings us to an even more mind-bending concept: the multiverse. Max Tegmark identifies 4 levels of multiverses, each one stranger and less intuitive than the last. Level 1 is the most straightforward and is actually widely accepted in cosmology. It is founded on the basic premise that space is infinite. Our observable universe is just a tiny bubble, the specific region from which light has had enough time to reach us over the course of 13.8 billion years. But beyond the horizon of this bubble, space continues. Out there are other galaxies, other stars, and potentially even exact duplicates of you and me, living in precisely the same conditions. They are simply located so far away that we will never be able to observe them. It's the same as looking out at the ocean from a small island. You only see your immediate horizon, but you know the water continues endlessly beyond that point. The second level of the multiverse stems directly from the theory of cosmic inflation. According to this theory, following the Big Bang, our universe experienced a period of extremely rapid expansion. This inflationary process, however, may never entirely cease. It slows down in isolated bubbles, creating universes like ours, but continues unabated in the vast space between them. These bubble universes could adhere to entirely different fundamental laws of physics. In one, gravity might be stronger. In another, the speed of light could vary. And in a third, completely different elementary particles might exist. Our universe, with its fine-tuned constants that allow life to exist, is merely one outcome among an infinite number of possibilities. We were simply lucky enough to be born in a universe where the conditions were suitable. This perspective elegantly resolves the philosophical question of why our world seems so perfectly tailored for our existence. But this is where the real magic happens. The Level 3 multiverse stems directly from the bizarre nature of quantum mechanics. According to the many worlds interpretation, every single time a quantum event occurs with multiple possible outcomes, the universe splits. All potential outcomes are realized, but each takes place in its own distinct, parallel universe. Take, for example, a radioactive atom that has a 50-50 chance of decaying. In one universe, it decays. In the other, it remains intact. And as the observer, you bifurcate as well. Your copy in one universe witnesses the decay, while your copy in the other does not. This suggests that an unimaginable number of your exact copies exist right now, living out every possible iteration of your life. In one of these realities, you never even clicked on this video. In another, you mastered Mandarin, and in yet another, you became an astronaut. Crucially, all these worlds are just as tangible and real as the one you are currently inhabiting. And finally, we approach the ultimate step in this bizarre cosmic hierarchy, the multiverse's level 3. This is the very embodiment of the mathematical universe hypothesis. While the preceding levels involved universes differentiated by initial conditions or physical constants, level 4 proposes that they differ in the very mathematical structures that define them. Tegmark makes the astonishing claim: any mathematically consistent structure exists physically. Our universe, described by the intricate equations of quantum field theory and general relativity, is merely one such structure. But somewhere, out there, other universes exist, founded on entirely different mathematics. Perhaps there is a universe built on 5-dimensional geometry, or one where the concept of time does not exist. Everything that can be conceived of as a rigorous mathematical theory is real. Imagine it as a colossal library holding every conceivable book. Each one represents a distinct mathematical structure. Our universe, then, is one incredibly thick and complex volume, brimming with fascinating narratives, like the emergence of life and consciousness. But on the shelves right next to ours sit countless other books. Some are mere pamphlets, detailing incredibly simple worlds where virtually nothing happens. Others are even thicker and more bewildering volumes than our own. As residents of our specific book, we can't physically reach the others, but we can use the power of mathematics to infer their existence. Under this concept, reality becomes infinitely richer and more profound than we ever imagined. Anything that is mathematically possible must somewhere, somehow, exist. It is the ultimate triumph of the imagination, rigorously underpinned by logic. So where does God fit into this? If the mathematical universe hypothesis holds true, it offers a very specific perspective on that question. This worldview leaves no room for the classic image of a bearded old man sitting on a cloud, orchestrating the cosmos. But that doesn't mean it denies the existence of some higher principle. If all reality is fundamentally mathematics, then God can be understood as that very all-encompassing mathematical structure. It's not a person, but rather the totality of all laws, all truths, and all possible worlds. This strongly echoes the concept of God held by philosophers like Spinoza, or scientists like Einstein, who perceived the divine in the inherent harmony and order of the universe. In this sense, studying mathematics and physics becomes a form of theology. We are attempting to read the mind of God, which means grasping the fundamental structure that gave rise to all existence. This kind of God is completely stripped of human attributes. There is no will, no emotion, and no grand design. It simply is. It is eternal, unchanging, and omniscient, but only in the sense that it is the very knowledge of all possible realities. This concept might seem cold and abstract, yet there is a certain grandeur to it. It posits that the universe is neither accidental nor meaningless. Instead, it possesses a profound internal logic and beauty, the inherent beauty of mathematical truth. In this context, our existence is not the result of a random roll of the cosmic dice, but a direct consequence of a specific mathematical structure, one complex enough to necessitate self-awareness. We are the means by which the universe observes and understands itself. There is something profoundly poetic, even spiritual about that, wouldn't you agree? Naturally, a radical theory like this attracts plenty of critics. One of the main arguments against it is its unfalsifiability. In science, a robust theory must make predictions that can be tested empirically. If an experiment fails to confirm the prediction, the theory is disproved. But how do we test a hypothesis about the existence of other universes governed by different mathematical rules? By definition, we cannot interact with them. Tegmark argues that his theory does make some predictions. For instance, that we will continue to discover more and more fundamental mathematical patterns underlying physics. However, many scientists view this as far too weak an argument. They contend that the mathematical universe hypothesis is more akin to metaphysics or philosophy than actual science, precisely because it is impossible to refute. Another significant objection revolves around the so-called baggage problem. Critics question, if every possible mathematical structure truly exists, why do we find ourselves in this specific, complex structure, rather than a vastly simpler one? Tegmark addresses this using the anthropic principle. Only structures complex enough can give rise to observers capable of asking these kinds of questions. In a simple universe, perhaps one consisting of just a single number, there would simply be no entity to realize its own existence. However, this answer is far from universally satisfying. Furthermore, the fundamental question of consciousness remains unresolved. How exactly can a purely mathematical structure give rise to subjective experience? The sensation of seeing red, or the taste of chocolate, This is arguably one of the toughest challenges the mathematical universe hypothesis faces, and so far, it offers no compelling solution. There is also a more grounded version of this idea that has become incredibly popular in recent years, thanks to Elon Musk and other thinkers. This is the simulation hypothesis. It posits that our universe is merely a computer simulation, created by some highly advanced civilization. In this scenario, the laws of physics are nothing more than lines of code, and elementary particles are the pixels on a giant screen. This concept feels much more tangible than an abstract mathematical structure, precisely because we ourselves routinely create simulations in computer games. We can easily imagine the programmers who initiated our reality. Crucially, this hypothesis, unlike the mathematical universe hypothesis, even offers potential ways to test it. For instance, scientists could look for bugs or glitches in the matrix, small-scale violations of the known laws of physics. How exactly does the simulation hypothesis connect with the mathematical universe hypothesis? Essentially, a simulation is just a specific instance, or a subset, of a mathematical structure. After all, every single computer program is an algorithm, and algorithms are fundamentally defined and described mathematically. Therefore, even if we are living in a simulation, we are still fundamentally residing within a mathematical universe. The key difference is that in this scenario, the universe's creator isn't some abstract Platonic realm of ideas, but rather tangible, real-world programmers operating in a higher reality. However, Tegmark's hypothesis goes deeper. It is far more fundamental. It posits that the universe requires neither a computer nor programmers to exist. The mathematical structure is reality itself. It doesn't need to be run or instantiated on anything. It simply exists in and of itself, solely because it is mathematically consistent. Let's come back to our world and see how this hypothesis changes the way we look at familiar concepts. Take time, for example. In our common perception, time flows steadily from the past into the future. But in most fundamental physical equations, time is simply another dimension, just like length or width. The mathematical universe hypothesis takes this idea to its logical extreme. If the universe is a four-dimensional mathematical structure, 3 dimensions of space and 1 of time, then all moments in time, past, present, and future, exist simultaneously and are equally real. Your birth, the precise moment you are watching this video, and your old age are all simply different coordinates within this fixed structure. The sensation that time is flowing is an illusion, generated by our consciousness as it processes this structure sequentially. But what about free will? If the future is already written into the mathematical structure of reality, does that mean all our actions are predetermined? Not exactly. Think back to the multiverse's level 3, quantum branching. Every single choice you make creates a new universe. When you decide whether to have coffee or tea, the universe splits. In one branch, you're drinking coffee. In the other, you're having tea. Both of these realities exist. Your free will isn't about choosing one option over the other, but rather about which of your infinite copies observes which branch of reality. You aren't choosing the path. You simply find yourself on one of the countless paths that all exist simultaneously. That's a very strange way to understand choice, but it logically follows from the idea that everything that can happen, happens. This theory also offers an elegant solution to the paradox of the beginning of time. What came before the Big Bang? This question consistently stumps traditional cosmology, since prior to the Big Bang, neither time nor space existed. But for a mathematical structure, the entire concept of a beginning is meaningless. Does the number 5 exist in time? Did it have a starting point? No, it simply is. It exists outside of the constraints of time. In the same way, the mathematical structure of our universe simply exists. It was not created. It did not emerge from nothing. It is inherently eternal. The Big Bang, therefore, is not the start of existence itself. It is merely one specific point within this larger mathematical structure, a point we designate as the beginning, due to our internal, subjective perception of time. This completely eliminates the need for a first cause or a creator in the traditional, theological sense. Yet why this particular mathematical structure, and not some other? Why is our world described by quantum mechanics and the theory of relativity? Tegmark suggests that different mathematical structures might possess varying degrees of complexity. Perhaps there is a principle similar to natural selection that favours more complex and stable structures, those capable of generating self-aware observers. Our universe may have turned out to be the winner in this cosmic competition among structures. Or perhaps all structures are equally real, and we simply find ourselves in this particular one purely by chance. This is one of the deepest and most unresolved questions surrounding this hypothesis. Finding the answer to it is, arguably, the main task of 21st century physics. Ultimately, the mathematical universe hypothesis forces us to radically rethink the very concept of existence. What does it truly mean to exist? We are accustomed to believing that only physical objects, things we can touch, are real. But this theory posits that the most fundamental level of reality is actually composed of abstract ideas, relationships and laws. Matter, energy, space, and time are merely manifestations of a deep, underlying, mathematical essence. This is a universe where ideas are primary and matter is secondary. Embracing this viewpoint requires an enormous intellectual leap, one comparable to the shift from believing in a flat Earth to accepting a spherical one. It reshapes not only our understanding of the cosmos, but also how we see ourselves as conscious beings, born out of this incredible mathematical symphony. Let's quickly summarize. Max Tegmark's mathematical universe hypothesis posits that reality isn't just described by mathematics. Reality is mathematics. We are all simply self-aware components of one gigantic and incredibly complex mathematical structure. The most astonishing implication of this theory is the existence of the level 4 multiverse, where every mathematically consistent system constitutes a separate real universe. Our world is just one among an infinite multitude. So, is God mathematics? The theory doesn't provide an answer regarding the existence of a personal God, but it does suggest that the fundamental basis of existence, the very blueprint or code of reality, might be the eternal and perfect realm of mathematical truths. Perhaps the mind of God that Einstein spoke of is in fact this all-encompassing structure. Thank you for watching this video until the end. If this theory blew your mind as much as it blew mine, please be sure to hit that like button and subscribe to the channel so you don't miss our next journey to the edge of science and philosophy. What do you think? Are we living in a mathematical universe? Or is math just a convenient tool invented by humans? Let me know your thoughts in the comments below. I'm genuinely interested to read them.